Hello viewers, welcome you once more again to AB Math Education YouTube channel. Please take just a few minutes, subscribe, like the video so that you can always see the new lesson when we post it. Today we are going to look at some theorem that students actually find it difficult to understand, which we can able to do activity to bring out the understanding. They will discover it themselves, so it won't be difficult for them to do as they move forward. So in this video we'll be looking at why the sum of a triangle is equals to 180. We will also be looking at some of the corresponding vertical opposite and the alternate angles. Why are they congruent? We will also be looking at the mixed segment theorem too. So here I have already done this with my students. All that we have to do, just let them draw two different triangles with different sizes using the ruler and the compass. They should make sure that the triangle is reasonable enough for them to. And then we have to also teach them this because they find it trouble to measure an angle using the protractor. So they measure the angles in each triangle and then let them add it up in each triangle. And then after that, they can write their observation. So when we did it in class, they measure the A, B, and C. We have different kind of groups. So when they added it up, we realized that one of the group was getting 181, 181, 180, 183, 181, 180, 179. But in all, if we run it to the nearest whole number, the number that we are approaching is 180. So here they have to be able to conclude that when they measure and they add up in each triangle, they are getting 180. Some of their observation is that it doesn't matter the size of the triangle, it was still adding up to 180. Now they see that it doesn't matter. Anytime they have triangle and they add it up, it must be equals to 180. And so that was discovery in this kind of all right. When it comes to the exterior angle theorem investigation, you draw a triangle and then I ask them to extend it so that we will have exterior. So here the C is outside, so I ask them to measure individually angle A and B and then record it and add them together, and then measure the angle C by itself and recall that these are the groups what they came out with. So one of the group came out with, when they added the A and B, the angle A and B, they got 130, 134, 124, 139, and so forth. Remember the angles, I didn't draw the triangle for them. The triangle, they drew them by themselves. So it was a different triangle. That's the reason why we are seeing the different angles here. And then when they measured the angle C, you realize that those who go 130 for adding A and B with the C, they get 130, 134 for angle A plus B, and then they got angle C, they got 134, and so forth. Here comes the question. I asked them to write their observation between the exterior angle C and then the sum of the A and B is made that equal. So here we were able to conclude that when we have angle A plus angle B is always equals to angle C. And this is indeed the sum of exterior angle theorem. So they were able to see themselves. So when I give them the question later on, I believe they can able to see that, oh, indeed, when I have angle here, I add this two interior, it must be equals to this. And that can able to help them. And if they have any missing, if here is missing along the line, they will see that, oh, if these two add up to give you this, then if I subtract, I can able to get that.